forward with your problem so that we can handle. If you just struggle yourself, then you will be wasting your time. Let me see. Okay. Take your seat. Okay, all of you please log into your Blackboard.
I did already, sir.
All right. So those who just moved in, you need to make it fast. Log into your Blackboard and confirm, because we are going to do one activity as a group. I'll be doing here and you all going to follow. Still people are walking in, so we need to wait for a few more minutes. Come on, get settled fast. Log into your Blackboard. Log into your Blackboard and get ready for one lab.
Sure.
We are going to do this lab, the very first lab it is. LVML, Networking Technologies and Architecture Prerequisites. I see none of you have taken this lab. I don't know why. It is a required lab. Some of you started doing labs, but this is, I don't know for what reason this one is skipped. All right, do this lab right now, all of you.
Yes, sir.
Yeah. What's your name? Nigel? Have you done any other lab except this? So what, okay, if it is not showing up in your blackboard, then do it again. Okay, I'll see it later. So welcome to the networking topology characteristic practice lab. In this module, we provided with instructions and devices needed to develop your hands-on skill. And network topology can be considered how different devices on network are connected. Okay, 1 minute. There is something wrong with this. Hold on. Okay, leave it. I think it's given as a prerequisite, but it's not as prerequisite. All right, hold on. We are going to discuss few things and then we will go. What do you know about network? What do you know about network? Are you leaving? Sorry? Okay. What do you know about network? Are you connected to a network? All the time? All the time, every time? If
It's
you are
also
using
an arrangement of intersecting horizontal and vertical lines.
yeah. So if you are using phones these days, you are connected to a network, right? Some networks are visible, right? Have you seen any network? Have you seen any network? Like? Come on. Power lines? Couple of computers?
TVs.
TVs? Cables? Right, cable TVs or cable network where you have a dish antenna on top of your house roof and you can watch TVs. That is also a network. Some networks are visible, some are invisible. What is? This is next room? This next room? Yeah, this is these all are the networking devices. You will, if you are going to do Cisco class ever, Cisco class, you can use or you will be using those devices which are in the very next room here. We will be talking about those devices in this course, but we are not going to use any one of those. Okay, I may take you in that room someday and you can see them or see those devices personally. But networking is the need of the day. Without network, we cannot survive as such. Whether it is banking system, we need network. We are connected to the medical system, we need network. We are in this college studying because of the network. We can see this PowerPoint presentation here on the screen because of network. Your phones are connected to a network. These all computers are connected to a network. In whichever field you go, there is a network. Someone said power lines. Power lines is very good example of network which you can see. You can see power lines everywhere in the city. Some are big power lines, some are small power lines. Big power lines, the high transmission lines, and small ones which are basically supplying power to individual houses, right? You have, some of you may be having cable network at your home, some of you may be having cable internet at your home, some of you may be having fiber internet at your home as well. Everything is network. We are now able to communicate with our friends and families which are very remote to us, whether they are here in the States or in this country or in a different country. We can do video chats with them, video calls with them, and whatnot. Everything is because of network. And it is growing. We are going out of this earth as well. We are going to space. We are now communicating with some people or some of our astronauts living in International Space Station. And we are, people sitting over here, they are communicating with them as well. We are controlling our satellites from Earth. It's all happening because of network. Now, as I said, some networks are visible. Means those networks are using wires. Like these computers, you can see a blue color wire in every computer, at the back of every computer here. If you turn your face, not the last row, if you turn your face, you can see a blue color cable in these computers, right? That blue color cable
today's
is...
class lesson is about networks?
Pardon?
Today's lesson is about networks?
Yes, that's right. And did you study anything else? Sorry. You studied anything else for today?
The networks are linked.
Yeah, linked devices, right?
Yeah.
Devices which are connected to each other. Right?
Linked to each other.
Yeah. Now, if I ask you, are the cars connected to each other?
No.
Yes? Yeah, these are. These days we are talking about connected cars, right? Tesla cars. Mostly Tesla cars or some of the other companies are talking about connected cars. The technology where car can talk to each other so that we can avoid accidents, so that we can avoid any kind of congestion on the roads. So, as I was talking about, there are two types of networks, mainly in terms of visibility. The one which are visible using cables, all kinds of cable communication, and other ones are invisible networks. Means we are connected to a network but we cannot see the network, like Wi-Fi, like these mobile networks, right? These are the networks which are using some kind of invisible transmission technology with the help of which we are connected. Our signals, because in the network we need signals, data is signal. So signal travels through the wire. Wire can be an easy medium for transmitting our data from one place to other place. Now, if it is invisible network like Wi-Fi, then how the data is traveling from one place to other? So there also we are having, or we are using some kind of carrier waves. The waves which can carry the data from one point to other point. So data does not travel by itself. We should keep this thing in mind. Data can never travel by itself. Data is nothing but, what is that data? How we represent data? Zeros and ones, right? Have you studied bits and bytes? Right? So data is represented by zeros and ones. So data cannot travel by itself. Data doesn't have legs. Data is not wave. So data cannot travel. So data need to be transported with the help of some kind of carrier. So in the wire, it is traveled with the help of electrons or light waves or something. In air, it is traveled with the help of carrier waves, microwaves. Microwaves. We say microwave is a device where we can warm up our food, but that is also a form of wave which kinds of increases the speed of the atoms in your food or in the liquid, and that liquid or food heats up. Same is happening with the. So here we are going to study about a lot of things in networking. I will again welcome all of you to ask questions. So here we are going to talk about this is interview simulation, so I will skip that part. By the way, it's an icebreaker, means you should know about each other here in the classroom. That may help you in doing some projects later. But here we are going to do project individually. Okay, so we are going to compare peer-to-peer and client-server network model. We will identify different types of applications and protocols used on a network, describe various networking hardware devices and most common physical topologies. Compare the 7 layers of the OSI model. So a lot of things we have in first chapter. Explain the best practices for safety when working with networks and computers. Apply the 7-step troubleshooting model for troubleshooting network problems. So these are the objectives of today's lesson we are going to cover. So network models, basically various terms we are going to use in this class throughout the semester. So you should remember all these terms very carefully. Topology, basically the arrangement of computers or arrangement of network devices connected each other. So we will be discussing what topologies are there. Physical topology, logical topology. Physical topology, as you can see, the computers are arranged in a particular pattern in this room, right? That is the physical topology. You can see there are some devices in the next room arranged in a proper manner. That's a physical topology, in which physical manner devices are arranged. Logical topology, where we say that we are connected but we don't know how we are connected. You are right now you are connected with your friends and families through the mobile network, but do you know how we are connected? My phone is connected to which network, which tower here, which Wi-Fi connection or Wi-Fi router here? We don't know, but we are connected. We know we are connected, but we don't know how. So that is your logical topology. So whenever you say, oh, we are connected, but I don't know how we are connected. I can communicate to my friends, I can communicate to my family, but I don't know how. Logical topology. And the network operating system. The network operating system is the now you know operating system. I hope you all, have you done that class, operating system? Or which operating system you know, by the way? Windows, right? Last week also I asked this question, I believe. So you all knows Windows. What other operating system we have in the market? Mac OS, Linux. Anyone else? Anyone else? Unix. Do we have Chrome? Chrome is also used as an operating system these days in some of the laptops, some of the computers. What operating system we have on phones? Android. One of them. Android is basically a base operating system, but Android is not exactly our Android operating system which we are using exactly on our phones. It's a modified version we use on our phones. But what other operating system we have on phones? iOS. iOS is used on Apple iPhones, right? So operating system which runs a particular device, right? Which runs a particular device. Network operating system is an operating system which controls the networking device. Any kind of networking device you see, is it a switch? Have you seen a switch? No, don't worry. A router, you might have seen router at your home, right? Internet router. So these type of devices, we have like one here. These type of devices uses network operating system. Okay? Network operating system. So network operating system controls the access to the entire network, and it's not just one operating system which controls the entire network. There are multiple devices, some 10 devices or 100 devices or thousands of devices are running in the network in order to control the network. And we are basically, we humans, or we, like you guys, going to be an expert someday, you are going to control those networking devices. Once you configure those devices can do their job by themselves. But first of all, you have to configure them. When let's say you are getting a new internet connection at your home, someone came in from the service provider's company with the router, they set up the router in your home. First day they need to set up the router or the networking device in your home. After that, it keeps on working. It keeps on working. If it goes bad or if there's some kind of technical problem, then only you need to change it and reconfigure it. Otherwise, you don't need to do anything with that device. It's not a daily job. So that is your network operating system. So every networking device. Now, if I say, or if someone asks, hey, is this computer has network operating system? Yeah. You may say that because this computer is connected on a network, then it must be having a network operating system. But no. Operating system is one. Network operating system, generally when we are talking about a device which runs only and only for network management. This device network is controlled by the operating system of this computer, which is your Windows, and which is Linux or Unix or your mobile phones. Right? So, physical topology, where you are looking at the physical arrangement of the networking devices. Logical topology is how everything is connected. Peer-to-peer or P2P network model, when you are having two computers or multiple computers connected to each other and controlling each other's resources, that is your peer-to-peer. In the peer-to-peer system, we do not have a one controlling server or one controlling computer. For example, your house may have 4 or 5 computers. In your house, you may be having 4 or 5 computers, isn't it? Right or no? Yes or no? Right? All those computers are individually working. Do you think they are connected to the same network? Yes, they are connected to the same Wi-Fi network. If you wanna see or you wanna connect to each other's computer, you can do that. In your home network, you can connect to each other's computer. That will be a peer-to-peer because there is no controlling server. There is no server where you are logging. But this network here you are using your student ID. You are using your student ID to connect or to log into these computers. Now this student ID is verified, authenticated or verified by one server. Someone is or some server is verifying or authenticating your student ID if your student ID and password is valid. If you do not type the right password, then you will get error message. You cannot log in. Now who is verifying that student ID and password? So there is a server sitting somewhere. So what happens is, the very moment you type an IP, a user ID, so there is a server sitting somewhere in the network. You are sitting here in this classroom. You type your user ID and the password. Immediately this server, with the help of network, send the user ID and password to the server. Server verifies if this user ID has this password, it sends the acknowledgement back, yes or no. Accordingly, you see the message on the screen. If it is not matched, so the server, what the server has a particular user database. A user database is there on that server. Server matches your user ID and password. If it is matches with the database information, you will get the login. Your login is successful, otherwise it is error. So here it is controlling. So it is your client, it is server. So it is a client server network. It is a client server network. Now, opposite of this, opposite means where we do not have such server. Where we do not have any such server, but still we can log into our computer, then how does it happen? So in that case, every computer also has a user and password information is stored in its own database. That is called local user account. Local user account. Local user account. Do you know what is the local user account of these computers? Huh? Law student B, right, by the room number or building name. That is the local user account. Every computer is connected to a server and also connected to itself. So if you are using local computer account in these computers or in these machines, you are connected to the local computer. If you are using your student ID to connect to these computers, you are connected to a client server network. So there are two topologies basically works in these computers. One is peer-to-peer, where you are connecting to the local account of the computer, and one is client server, where you are connecting to a server account on this computer. Is that making any sense? For example, in another example, you all stay in your home, but you come to the college. When you are in the college, you are client and college is a server. When you are at home, you are peer. You are all individually at your home. You are connected, but you are not associated with the college at that time. You are in your homes. So that is peer-to-peer network connection. When you are here, you are client and college is the server. So client and server. The one who has a requirement and a one who is providing or fulfilling your requirement. It's not necessary that this client server network exists only in the college or student. It is anywhere where we need something and someone is providing that need to me. For example, you are going to hospital. You are the patient and the doctor is providing or taking care of your need, or the hospital is taking care of need. So you are the client, those are server. Someone is coming to you, you are working somewhere, someone is coming to you with a need, so you are fulfilling that need. So you are client or server? Server. You are the client, and the person who has the need is the client. So wherever there is a need and serving, there is a need and there is a serving. So need is the client and serving is the server. It could be anywhere, banking system, hospitals, grocery stores, college student, wherever you have this kind of transaction happening, it is a client server. Someone has a need, another one is providing that need or fulfilling that need. It's a client server. When you open the browser and you type www and something.com, website opens. Now can you tell me who's the client and who's the server?
You.
Say it loud.
You are the client.
Okay, good. So generally we think that way, that we are the client and the server who is fulfilling that website is the server. But the browser in which you are typing that www address is the client, and the server who is fulfilling that website is the server. Right? You are the client of this computer, but application is generally the client. The application which you are using is the client. For example, you open the web browser and you type open the Blackboard, right? So don't say that I am the client. Your application is the client. Your application is always in computers. Application is going to be the client, and the server is whichever is providing that data to that browser, right? So we'll be looking at more. So computers, now who can be the, in case of peer-to-peer, let's say printer. Think about the printer. How many of you have printer at home? Okay. So what you do with the printer? What you do with the printer? Printing, right? So how you print? You send the command, or you open the print command, or you print instructions and printer prints. Now printer is connected. Do you need to log into the printer? No, you need not to log into the printer, right? So it is a part of network. It is a part of your home network, but I don't need to log into that network. So it is a peer-to-peer network. It is a peer-to-peer networking model. In peer-to-peer networking model, we don't follow very strict security. We do not follow very strict security. Most of the communication happens without any authentication. Okay, it is less expensive to the other network models. We don't need too many devices in the peer-to-peer network. We don't need too much of security in peer-to-peer network. And every user has an individual account independent of any server. Now, but what is the major challenge with the peer-to-peer? Not scalable. Means we cannot scale it up or down. It's not that easy to add more devices to it, or generally we do not consider it as scalable. Anyone can come to your house and connect to that Wi-Fi network if the person has the password, or anyone can work independent of the Wi-Fi anytime. You can bring your laptops here and don't connect the network. Can you still work on your laptops? Yes, because it is a peer-to-peer network. Your all laptops are independent of this college network. These all laptops you are carrying right now, they all are independent of this college network. It's a peer-to-peer network. But these computers, these desktops, they all are connected to this college network. They are the part of one common network. So they will be using our next model, which will be, so this is an example of peer-to-peer network. It is not necessary that all are connected by wire only. It can be Wi-Fi, or it may not be connected at all. It may not be connected at all. The next model is client-server model, which I explained to you with the help of one diagram. Now, in the client-server network model, we always prefer one central server. There is always one central server sitting somewhere in the network. In this network also, we have one server sitting somewhere in this college network, and all these computers, if you are using your student ID, only if you are using your student ID, that server is going to authenticate your student ID, your account. That account will be authenticated by. Now, if you are using your Blackboard application, if you are going to Blackboard, on the Blackboard with the help of browser, you are going to provide your user ID and password. There is a server somewhere which is authenticating your user ID and password. If your user ID and password is valid, then only you can access your content on this Blackboard application. If your user ID password is invalid, you won't get anything. Will you? No, you won't get anything, right? So it is again a client server network. Every time you authenticate, take the example of your email. If you are logging to your email account and do not provide the right password, will you get the email or can you send the email? No. So who is your client and who is the server in case of email? Tell me, who is the client and who is the server in case of email? Think wisely. Think wisely and tell me. Again, you are going to the people. Don't go to the people. Don't go to the individual. Who is the client and who is the server in case of email? Outlook is the client. And do you know the server name? Application? Exchange server. We call it Exchange. Microsoft server. Microsoft email server name is Microsoft Exchange. There are many other servers exist. Other companies are using different types of servers. But email server. So don't think that if you are using computers, then don't think that you are the client. Don't consider yourself as a client. Always think about application. So for example, your browser is the client. If I'm talking about client application, your browser is a client. Your Internet Explorer, Chrome, Mozilla Firefox, all the browser. Your Outlook is a client. Your Outlook is a client, right? As of now, we are using only these two applications mostly. As a client, I'm not going into more applications as of now, but there are many other applications which exist and we are using them or will be using them as a client, right? And there are server applications. So web server is providing the content to the browser. Exchange server or email server are providing the content to your Outlook or to your browser email client. So these are the client server applications, and every client must have a server. Now you are using MS Word. So think about MS Word. In the MS Word, you open the print and you send the print command. So and print goes to the printer. So who's the client here? This MS Word is the client, and who's the server here? Printer is the server. Printer is processing the command. Printer is processing the need of that printing. So printer is the server. This is your server. So that's how you are looking at client server networking. Now there are many other applications we use. Okay. Now for the authentication purposes, we have an application called Active Directory. This is by Microsoft. This Active Directory is a centralized directory. You can consider it as a database, but it is a service by Microsoft which runs on a server, and we call it domain server. So in Windows network we call it domain server, and in Linux network or Linux or Unix network we call it NIS server, NIS. Okay, or LDAP. These are some names we use in Linux or Unix environment. NIS or LDAP server. In Windows we call it Active Directory server or domain server. Active Directory or domain. So what it does? It is basically maintaining the information about all the users and their passwords and their permissions in this network. For example, if you open your, can you open your OneDrive? You can open your OneDrive. Have you seen OneDrive? Right? You can open your OneDrive, but can you open others' OneDrive as well? No, that is a permission. So you don't, or we don't have permissions to access others' OneDrive. So everything, all that information is stored here in this Active Directory Windows domain server. Your user ID, your password, even your all login activities. When did you log in? On which machine you logged in? What was the time of your login and logout? All information about your login activities. Or if you log into this college, or you log in from outside using your laptops, all activities are recorded in this Active Directory server. Okay, so don't think that I'm not traceable. Every one of us traceable if you are connected to the network, right? Security agencies can, this way they can track each one of us with the help of our mobile phone, with the help of our CCTVs, with the help of our call logs, with the help of our location tracking. They have so many measures or items to locate our, or to identify us, or to find out what we were doing at a particular time. So client server is, user can sign into the, user can sign into the network from any computer on the network and gain access. So this is the benefit of client server. It is not necessary for you to sit on particular computer and then only you can work on your account. Today you are sitting here, tomorrow you can sit there, third day you can sit there, and you can still use your account. Today you are sitting in this room. For the next class you will be sitting in some other room. But can you still use your account? Yes or no? Yes. So how is it possible? Because of the same reason, everything is connected to one server. Client, server. All these computers are clients. Excuse me. So Active Directory Domain Services, ADDS, that is the important part of the Windows network for client authentication. Okay, so centralized management of user account, network can be monitored from one location, more scalable. I can add as many user accounts as I want. Today we have 10,000 students in this college. Next semester we may have 20,000 students in this college, but we can easily expand the network. Do I need to add more resources? Maybe not. Because we are just need to handle the student placement in this college. And this is how the logically how this network looks like. So these computers are not directly connected to the server as it is shown in this picture. This picture says computers are directly connected. Answer is no, they are not connected directly to one network, and it is not possible. How does that happen? So let's say this is my building B, and this is the server located in building A. This is my server. This building B has many rooms. These are the rooms in building B. 1, 2, 3, 4, 5 rooms. These 5 rooms. Every room has 40 computers. 40. Let's say this has 60 and 60. So how these computers are going to be connected to this server room? So there is a switch. We are going to use switch. In every room we are going to use a switch, and then we are going to use a switch for the building. So all the computers are connected to this switch. All the computers are connected to this switch, and all the switches are connected to this switch. All the switches are connected to one switch, and then this switch is going to connect to this one switch in building A. This is another switch here which is connecting to this switch. So it may be like this. I'm not saying that it is exactly, but I'm giving you a rough idea that how things works in the network, how multiple computers are connected to one computer.
Oh, is that a switch right there, up there?
This is for Wi-Fi.
Oh, okay.
This is for Wi-Fi. Now, all the Wi-Fi, let's say every room has a Wi-Fi switch. Every room has a Wi-Fi switch. So these Wi-Fi switches are also connected to this switch. Connected to this switch here. And then they are connected to the server somewhere in building A, for example. Okay, so it's not that one-to-one connection or direct connection. It is always distributed. It is called, this topology basically, it is a kind of topology. We call it topology. This is topology. What is the picture represents? This picture represents. What figure it represents?
Star.
Not network. I'm talking with what kind of figure it represents.
Star.
Star. So it is like figure representation, how the figure, for example, if I draw one line, this is single line, see? So if I say what this figure represents, a line. If I draw this, what this figure represents?
Mesh.
Circle. It's a circle, right? So we have topologies in this form. So there are forms of topologies, so we'll be talking about that. But just keep this thing in mind, that how these devices are connected to each other. They are not directly connected. Okay, so what happens, let's say in this room itself, there are two computers, and this is the switch. This computer is connected to this switch, this computer is connected to this switch. If they want to communicate with each other, so they are not going to send message directly, they are going to send the message to the switch. Switch identifies which computer this message is for. This message is for which computer? So if this switch identifies and sends the message to the particular computer. If you want to send, let's say you want to send some message or you want to say something to someone, what will you say first? You want to say something or some message to someone, to your friend, let's say in this room itself, what will you say first? Greet them, right? You greet them. How you greet? Hey Sandeep, how are you? Hey Sandeep, listen to me. So what is that? You are calling name. You are calling name. You are calling name because you want to take attention, because you want to establish a communication with your friend or with the person you would like to communicate with. If you want to call someone, what you do? You have a phone number of that person, and that phone number belongs to that person. So every person has an identity, whether it is a name or it is a phone number. So do you think that these computers also need an identity? Yes. So these computers also has some identity to communicate over this network. Now if you know or if you notice that every computer has a unique name. Every computer in this room has a unique name. And it has a label also, but if you go inside these computers, you can find the name of these computers. Let me show you where you can find the name of these computers. So if you go to, excuse me, if you open the Windows Explorer, this window, right? right here, and right click on this PC. Right click on this PC here. You see that this PC here? This PC, right click on this PC and go to properties. Properties. Uh-oh. It is actually when it's duplicating the display, so it is coming on my second menu. Where is my mouse? So if you see, you can see the name of this computer. Just check the name of your computer. Check the name of whichever computer. If you are using laptop, still you can check the name of your laptop. Still you can check the name of your laptop or check the name of your computer. Every is any computer has the same name?
No, the number is different.
Number is different. Law, Lawrenceville. B, building 108, room number 00, the computer number. That's how they named it. So every computer has its own name. This is how the computers identify each other, but not always. So every computer also has something called IP address. IP address is the one computer thing or the digital thing which every computer uses to identify each other in the network. IP address. So you will be or we will be dealing with IP address for rest of the time. Even if you are cybersecurity major, you need IP address or knowledge of IP addresses. If you are networking specialist, you need IP addresses. If you are data center specialist, you need IP addresses. If you are gaming, then also you need IP addresses, because these days we are playing gaming over network. So wherever there is a use of network, you need to know IP address. What is IP address? So we will be talking about IP address later, but let's come back to the presentation. Okay. All right. So computers are connected, but if you are not the part of, if I'm not the part of this college IT team, so I don't know how exactly these computers are connected to the main network, where the cables are. All the cables are underground. All the cables are underground in this room, in this building. You can see somewhere on the floor, you will see cables are going down. Just look at here on this table. Every table has one end going down. Cables are going down, whether it is power cable, network cable. Not every table, every row. At one corner, like there and there. Below the first table and below the last table on this side, there are cables going down. So all the cables are going underground in every room, not just this room. Okay. Network services. Now there are network services. Every service which runs on network is a network service. Any service which runs on network is a network service. So without network service, nothing can work on network. For example, Active Directory, your login authentication, your email service, your file transfer. You are transferring the file from one place to other with the help of network, file transfer service. Your printer, you are sending the print command and printer is printing it. It is not going over the thin air. It is going through the network. You are sending messages. You are calling someone on your phone. Network service. Everything is a service running on the network. So all resources, the network services are the Just a minute here. Okay, network services are the resources and network makes available to its users include. So all the everything you are doing on network is because of network services, and we will be learning about those network services very soon. But some of them are email service, right? Network printing service, file transfer service, right? Your entire internet is running because of network services, right? And there are many services combined we use on network. So we'll be talking about those network services. For example, here you are sending some information or sending your user ID. You are uploading, you are submitting your assignments with the help of network service. For internet, the service name is HTTP internet service or web service. You just call it web service. For file transfer, we call it FTP. For email, SMTP. We can just keep naming it, but as of now it's no use. But we will be coming back to those services in later chapters. Protocols. So protocols are methods and rules for communication between networking devices. We can understand each other because we know some common language. Isn't it? That's the protocol. That's the protocol that I will speak in one language which you all can understand. But each one of us, most probably, each one of us must be knowing a different language as well, which may be your native language, or maybe anything else you might have learned in your school. If you start speaking in that language, then some of us may not understand. Because of this protocol, these computer knows that in which language we are going to talk or we are supposed to talk, so that we all can understand each other. Right? In internet, you are getting data from all over the world. And nobody knows in which language or in which method or which operating system the other person is using. You might be using Linux, or you might be using Windows, you might be using Apple, any operating system, but we all can communicate each other because of protocol. You are using Apple iPhone, I am using Android, but still we can talk to each other because of protocols. So protocols are everywhere, not just in computers, but in mobile communication also, and in our person communication as well. In the person-to-person communication also, we follow some protocol. So protocols are nothing but the rules for communication between, here we are talking about network devices, so that's why we are saying between network devices. And there are two primary network protocols we use in these days in computers. One is TCP and other one is IP. TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. And IP address, as I said, IP address is the part of this Internet Protocol. What is Transmission Protocol? So all the services, all the network services are the part of Transmission Protocol. How the web data transfers from one place to other place, Transmission Protocol. How the file transfers from one place to other place, Transmission Protocol. How emails are transmitted, Transmission Protocol. So all web service, all the services, all network services are here, and all identification, location, tracking, IP, Internet Protocol. So, and the combined is known as TCP/IP suite, or suite, whatever you call it. This lays down the certain rules, and if you want to become a researcher in networking, then you will be focusing on TCP/IP. People can develop their own protocols as well if you study or you do some, let's say, PhD in computer science, then you may develop your own protocols. Okay, so protocols are not anything new or nothing new. We all knows about protocol, but we just learning a new term here, TCP, for transmission control protocol. So all kinds of services comes under TCP. IP, which is Internet Protocol. So your identification, location, tracking, that is all comes under IP. So if I want to send the data from one computer to other computer, so to identify the computer, IP will work, and to transfer the data from one computer to other computer, TCP will work. So to establish the communication, establish the link between the two computers, IP will work, and to transfer the data between the two computers, TCP will work. Got it?
Yes, sir.
And so these are the popular client server applications: web services, email services, DNS services, database services, FTP, remote access, and so many more. We'll be talking about most of them in this class. Okay, this is one example of SMTP, which is Simple Mail Transfer Protocol, used by email services or email applications, which is used for sending the email from one person to other person. Okay, now not just SMTP. So SMTP is a part of TCP/IP. So TCP/IP is a package. TCP/IP, it comprises many things. All kinds of network services are the part of TCP/IP, and all methods of identifying a computer over the network are the part of TCP/IP. Okay. All right.
So that probably won't have any encryption.
Pardon?
That probably won't have any like encryption or security, right?
Encryption and security will work in between, right? But yes, it depends, because encryption is an optional thing. You need to enable it if you would like to keep your data secure. If not, then your data will travel unsecure. So encryption, what the encryption means? Anybody knows? Data security, what the encryption does? Scramble the text or convert the text into a unreadable format, right? Unreadable format, so that no one can read it or no one can hack your data on the travel or on the fly, you can say. So there are multiple types of encryptions where you can say if the data is encrypted by the source. So here, if you look at this picture, there is a client, then there is a server, there is a server again, and there is a client again. Let's say you are sending the email from your Outlook to a Gmail client. You are sending the email from your Outlook application, but your email address belongs to a Gmail client. So this is your one server which belongs to Exchange, and this is another server which belongs to Google. So from your client, the mail goes to your server. From your server, it goes to the Google server, and then from the Google server, it goes to the Gmail client. You can start encryption from here. so that the data travels from your machine to other server is in the encrypted format. You can keep, and the server will keep the data in encrypted. It goes to encrypted to the Google server, and it goes encrypted to the, let's say Google says that no, I will not forward the encrypted message. So here, from here onwards, your message goes in plain text. Plain text. It is possible, right? You say that no, I don't want to encrypt my messages from the server to my application or my. But if it is encrypted, possible, then the decryption will take place here. Decryption will take place here, and the message will be decrypted so that you can read it. Now this encryption and decryption happens with the help of encryption keys. Encryption key. So I will talk about encryption keys later. There are two types of encryption keys. We call it public and private. Public and private. Right? We are only at 16th slide. I forgot the class time. What is the class time? 12? 15. So let's take a break for 5 minutes and then we'll continue.
10 minutes before.
Okay, yeah, so let's take a 5-minute break and then we'll continue. I'll be back in 5 minutes.
How do you get there, those PowerPoints? Yeah.
The way I did it was, I went to Blackboard. Go back to Blackboard. Go to content.
Okay. Lessons?
Lessons.
Aren't you there?
Sit down. Chapter 1 introduction.
Okay. Thanks.